Okay, the last two chapters where we have learned about exponents and polynomials have brought us here, talking about solving equations, which is one of the biggest things in algebra, is finding that infamous x. What value of x is it? So before we go anywhere, we do have to review the distributive property. Quite a while ago, we found out how the distributive property works, where when we looked at this, we distributed that 7 through. So if we look at 126 plus 35, we know that they both have that factor of 7 in them, because we know that because we multiplied it through. Same thing here with 2. Again, we distributed a p through. So what do 18p and 5p have in common? They have that factor of p. Because of that, we could combine them using like terms. Then we came down here where we did distribute, but we could not combine terms because of that variable b. But looking at this, now what we're going to do is called factoring. So what factoring is, when they say factoring, what they're doing is they're asking the question, what factor do each of the terms have in common? Okay, so what we're doing is we are hitting the reverse button. Everything that we learned last chapter, we're hitting the reverse button. So think about distributive property. We distributed a 7 through here. Now if they tell us to factor it, again, what factor do each of these terms have in common? They both have a factor of 7, because we know that we can rewrite 35 as 7 times 5. We know we can rewrite 7b as 7 times b. So what are we doing? We are going to hit the reverse button and we're going to take out the factor that they have in common, and we are going to leave everything else behind. We're going to leave the terms that do not have that factor behind. Okay, so when you see the word factor, what factor do each of the terms have in common? We're hitting that reverse button, taking out the common factor. Leaving everything else behind. In the parentheses. Okay, factoring in a nutshell, which is what we are going to do this whole chapter. So again, with these thoughts in mind, let's look at 2x minus 6. What factor do they both have in common? Well, looking at 2x, we could rewrite that as 2 times x. Looking at 6, we could rewrite that as 3 times 2. So what factors do they have in common? They have a 2 in common. So I am going to take that 2 out. I'm going to reverse distributive property, and then I'm going to say that what is left over is an x and a negative 3. Okay, does that work? If we hit the reverse button, this actually says 2x minus 6, so yes it does. So we did effectively factor this by taking the factor of 2 out and leaving the terms behind. I'm going to circle that a little bit better, that do not have that factor of 2. Okay, let's look at the same thing here with 27x squared and negative 24. A little bit harder to see, but let's look at 27. We have 3 and 9. And then, of course, we have that x squared. This pen is not working very well today. We have 3 and 9 and x squared. 24 has 3 and 8. Okay, there's a negative in there. So what factor do they have in common? They have a 3 in common. Notice I could have kept going with 9. I could have said 3 and 3, and I could have kept going with this and said 2, 2, and 2. But I knew right away that they didn't have that in common. Again, this is where knowing your factors is very important, because if you didn't know how to factor 27 and 24, you might take a long time with this. But I realized they both have a 3 in common. So I'm going to pull that 3 out, and say they have the factor of 3 in common, 9x squared as a term minus 8 is what's left over. Okay? So again, find the factor that's in common. Reverse distribute it out, write what's left over. So let's look at this one. We have no coefficient out in front of the x squared, so we have an x and an x. Here we have, I know that that's subtracting, but we have a 5 and an x. So what do they have in common? They actually have an x in common. So they have an x in common. I'm going to take that x out, and then what factors are left over? X and a negative 5. Okay, does that work? Yeah, because if I distribute that back through, there's an x squared. Here's the negative 5x. So sometimes factors are actually numerical values. Sometimes factors are actually variables. Okay, so biggest question, why on earth would we even want to do this? Well, there it is right there. Question 4, what value could x be in order for number 3 up here to equal 0? So let's look at number 3. We have x squared minus 5x. They want us now to set that equal to 0. And they want us to figure out what we're going to put in here for x. Well, we know how to solve equations that just have x with the exponent of 1. We've never looked at x squareds before, and so we're not quite sure what to do. But look at this. These both have just x's here, and we didn't have to deal with an x squared. So what are we going to do? Okay, to solve an equation, and this is called a quadratic equation. Why? Because it has a degree of 2. To solve a quadratic equation, what are we going to do? Factor. We are going to factor and get all variables to the first degree to have a degree of 1. Why? Because we know how to solve those. Then we are going to set it equal to 0 and solve. Okay? So again, what could we put in for this x in order for it to equal 0? Well, I know 0 minus 0 equals 0. So I think that maybe a 0 will come into play here. Okay, so I'm going to go ahead and look over here though, and it says factor. We know that we can factor this as x times x minus 5 equals 0. So I think 0 will work, because if I put a 0 in for here, right here, this whole thing would equal 0. Okay, so I know that x could equal 0. Am I running out of room? And the reason being is that if I put a 0 in here, 0 times negative 5 equals 0. So 0 times any number is going to equal 0. So if I put a 0 in for this guy, he's going to equal 0. Is that the only value though? What happens if maybe this parenthesis happened to be 0 and this was some other number? Okay, so what could I put in this parenthesis in order for this piece to equal 0? Well, that's where I'm going to set that piece equal to 0 and solve. So what could I put in for x minus 5 in order for that piece to equal 0? Well, if I added that over, I could put a 5 in. Does that work too? Well, let's look. If I put a 5 there and a 5 minus 5, does that equal 0? Well, 5 times 0 does equal 0. So when we are dealing with quadratic equations, 95% of the time, you are going to get 2 different answers. Okay, let's go back to here. Does that actually work with our very first quadratic equation? Well, if I put a 0 in here, 0 squared is 0, minus 5 times 0 is 0, equals 0. 5 squared is 25, minus 5 times 5 is negative 25, equals 0. It does work. Would that be a little bit harder to just kind of guess and check? Instead, factor, take out what they have in common, get each of our variables to have a degree of 1, and then we can focus on each one of those pieces and solve. That is the reason why we're factoring, and that's the reason why we're doing this whole chapter is so we can figure out what values of x are going to make our equation 0. We're going to solve for those. Why? So again, we can see how big we can make the outside of our pool because we only have a certain amount of room, or how much we should sell our brand new shoes in order to get the best price. Those are the types of problems that we are going to see in this chapter. Okay, so with all of that in mind, brand new concepts, using a review of different concepts that we've learned, go ahead and get out the notes and vocab for this section. Okay, objective of this section is to solve quadratic equations by factoring. And remember, we talked about what quadratic equations are. Equations with a leading degree, well, I'm just going to say a degree of 2. Okay, we're not going to call it leading because that deals with coefficients. But again, equations with a degree of 2. We knew how to solve linear equations because those were a degree of 1. So now we're going to take it up a step. Okay, so again, I have explained what factoring is, what product do we have in common. All right, so keep that in mind. When we start looking at example 1, it says we're supposed to use the distributive property to factor each polynomial. So again, sometimes the best way to do that is to go ahead and find the factors of each one of these. I know that 27 we could write as 3 times 9 times y. Okay, 18 I could write as 2 times 9 times y. Okay, now I'm going to look at what we have in common. Well, it looks like they have a 9 in common, but it also looks like they have 1 y in common. Okay, so again, use that distributive property. What factors do they have in common? They have a 9 and a y in common. Okay, then we're going to put that parenthesis and say what factors do they not have in common? Well, a 3 and a y for the first term and a positive 2 for the second term. So is that completely factored? Yes, there are no factors that they have in common here. If we did distribute this back through just really quickly to make sure, we would have 27y squared and a positive 18y. So that is completely factored. Okay, so here's a question. Does it work when we have many different, when we have more than just a binomial? Well, I think so. So let's go ahead and look at this. How are we going to factor negative 4? I'm actually going to say that it has a negative 1, a 2, an A, and a B. And I'm going to have to move that over because that's a lot of factors. Okay. Negative 8 has a negative 1, a 2, an A, a B, and a B. So a lot. And then here we have a positive 2, an A, and a B. Okay, again, what do they have in common? Let's go ahead and look through. I can see right away that all of them have a 2. I understand that these guys have more than one factor in common, but now that we're looking at a trinomial, all 3 of them, we have to see what they have in common. So I'm going to say they have a 2 in common. They have an A in common. Just one A, all 3 of them. The more terms you get involved, the more you have to look at that they all have to satisfy the same. So as crazy as it is, it looks like we have a 2, an A, and a B that are in common. Now's the fun part. What's left over? I have a negative 2A. I have a negative 4B. And I have nothing. I got rid of everything. So what do I put out there? Remember that notice here I said that they had a negative 1 in common. We always have that factor of 1. So I'm going to actually say out here that this is plus 1. Don't say plus 0. If you factor out everything, there's always going to be that 1 in common. So did we do it? Yep. It looks like we factored out all of the pieces that they had in common. We left out, again, I understand that this 2 and this 4 do have factors in common, but it had to satisfy that third term as well, and that did not. Okay, so to start with, this is the best idea. Figure out those factors until you get really comfortable with what factors they have in common. Okay, go ahead and give guided practice 1 a shot. Okay, on 1B, we really did have to be picky because we realized that the first 2 terms did have a 7 in common, but because that third term did not, we have to go ahead and bypass that as the common factor. And we had to just focus on each one of them having a U and a T as a common factor that we took out, and then we just wrote what was left behind. So that should say UT times the quantity of 7 UT plus 21T minus 1, because remember that negative is technically a negative 1 out there. Anytime you have a negative, that's probably the best idea, is to put it as a negative 1, because sometimes they actually do have that in common. Okay, so we looked at how to factor binomials and trinomials. Now we're going to actually look at 4 or more terms, and this is called factor by grouping. They show this here. It's really hard to see until we start actually throwing some numbers in there. So we're going to go ahead and look at that. All right, look at these 4 terms and quickly see if they have anything in common. Unfortunately, they don't. So it's really hard to distribute if we have nothing in common. So what we're going to do is we're going to do what's called factor by grouping. We're going to look at groups of them instead of the whole piece. Okay, so we are just going to factor 4QR plus 8R. Then we'll look at 3Q plus 6. So let's go ahead and factor 4QR. So I see that it has a 4, a 1, a Q, and an R. Why didn't I make 4 2 times 2? Because I know my factors. I know that 8 has a 4, a 2, and an R in it. Okay, so what do they have in common? They have a 4, and they have an R. So I'm going to say that just 4QR has a 4R in common. What are the factors that are left over? A Q plus a 2. Okay, now I'm going to go ahead and look at my 3Q plus 6. So I have 3 times Q, really no factors of that, and I have plus a 3 times 2. Okay, so those 2 pieces, what do we have in common? Looks like they have a 3 in common. So I'm going to say that these 2 have a 3 as a common factor. What's left over? A Q plus 2. Okay, now this is where it gets interesting, because now we are going to look at this as a term and as this as a term. Do you notice something? Do they have something in common? They have the factor Q plus 2 in common. So what we are going to do is we are going to distribute out a Q plus 2. We are going to say that they have the factor Q plus 2 in common. And we are going to multiply that by the factors that were left over, which are 4R and a positive 3. How crazy is that? Okay, so again, factor by grouping. You look at the first 2 terms, you factor them down. You look at the second 2 terms, you factor them down. Then we have to factor one more time. You should get a common factor. Even though it's a binomial, it is still a common factor, because factors mean that we are multiplying terms together. So we distribute out a Q plus 2, just like we know how to distribute. This is a little bit different. And then we multiply it by the factors that were not common, 4R plus 3. If you are skeptical with that and you don't think that works, go ahead, FOIL that thing through, distribute it through, and you will get that as an answer. Okay, this works when we are dealing with 4 terms. 2 and 3 terms, or sometimes even 4, if they have the same thing in common, go ahead. But if 4 terms do not have something in common for all 4, this is how we factor. Because this is kind of a different concept, let's go ahead and do 2A together, and then I'll leave you to 2B. Again, I see 4 terms. I'm going to quickly look through them and realize they don't have something in common with all 4. So I'm going to go ahead and just focus on my first two terms, and then I'll focus on my second two terms. Okay, my first two terms, what do I have in common? I'm not really going to factor these because I can see right away that it looks like they have an n in common. So I'm going to say they have an n in common. Factors that are left over are an r and a positive 5. Okay, this next one's a little bit tricky because we have a lot of negatives going on. So I know that that means that this negative r is technically a negative 1 times an r. Okay, this 5, so I'm going to add that to technically a negative 1 and a 5. Okay, so anytime that you see a lot of negatives, go ahead and do that. Write that negative as a negative 1 because look what I just did. Do they have a common term? They have a negative 1 in common. So I'm going to say what they have in common is negative 1. What are the factors that are left over? A positive r and a positive 5. So what did I do? I just changed the signs of those terms by taking out that negative 1. Okay. Again, there's step 1 of my grouping. Now I'm going to go ahead and realize that I'm going to distribute again. Now I see that they have that common factor of r plus 5. And the factors that are left over are an n and a negative 1. Mind blown, huh? This stuff is pretty cool, actually, to math nerds like me. Okay, so with that in your mind, go ahead and try 2b. Okay, and there it is. Remember that with the signs here, I would put an addition sign in here to understand that that negative 4 is there. If you do pull out a negative, technically that does turn into subtraction. So understand that sometimes we see it as a negative, but it does turn into subtraction, and that they really are synonymous because if we're adding the opposite, it's the same thing as subtracting. Okay, so just kind of keep in mind what that means right there. Okay, we have talked about additive inverses before. We just didn't really put a vocab word to it. Additive inverses are opposite signs. Okay, so when you see that, that just means that we have opposite signs. Okay, so please realize that 6 minus a is not the same thing as a minus 6. Look at the signs. This minus takes the place of the negative, so I see that this is a negative a, this is a positive a. This is a positive 6 and this is a negative 6. And this is where sometimes students see 6 minus a and a minus 6 and say, oh, they're the same thing. I'm going to factor that out. But that's not true. This is called additive inverses. So if this does show up, you're actually going to have to factor out a negative in order for the values to be the same, which is what we're going to look at in example 3. Again, I see 4 different terms. I'm going to quickly look. It looks pretty darn close until we get to that 7. He messes things up a little bit. So that means that I'm going to have to factor by grouping. And I'm going to put that positive in there because that kind of reminds me that that's a positive 42. All right, and here I go. Looks like I have a 2 and an m and a k. That was pretty straightforward. Okay, I have a negative 1, a 2, a 6, and an m. So if I do have a negative, I'm going to remind myself that that's a negative 2. Okay, so let me see. What do I got in common? I have a 2 and I have an m. So 2m are my common factors. A k, negative 1 times negative 6 is a negative 6 that's left over. Okay, 42, there's many different ways that I can factor that, but I'm going to quickly look ahead and see that 7 and realize I'm going to make that a 7 times a 6. Negative 7k, I'm going to call a negative 1, a positive 7, and a k. What do I got? I've got a 7 in common. So a positive 7 in common, and I have a 6 and a negative k left over. Now I have to look at this. These guys are very close, but again, we are going to call these, remember, additive inverses. close only happens in what, hand grenades and horseshoes or whatever. This doesn't work when we distribute because they have different signs. So what we're going to have to do is actually distribute out a -1 in the second term here. So I'm going to make this a 7. I'm also going to make it a -1, which means that if I take out a -1, my 6 becomes negative, my k becomes positive. So is that the same thing now? Do I have the same term here, the same binomial? Even though they're in different orders, I have a positive k and I have a -6. That does work. Okay, so I'm going to write 2m times k minus 6 here with a positive 7 times a -1 right here. Okay, so this is an additive inverse where I did have to keep going and take out a -1. Now let me see what I just did. What I just did was I do now have a common binomial. I'm going to rewrite this guy as k minus 6 because we like to keep the variables first. So I am going to distribute out a k minus 6. What factors are left over? A 2m, but now a 7 times a -1, which is a -7. Okay, as if factor by grouping wasn't tricky enough. Again, high level, keep that in mind. You might see this maybe once in assignments. So we're going to do 3a together just to make sure we understand the concept of this. Okay, I'm going to focus on factoring the first two and the second two. First one, I'm going to see right away that it's just a c that they have in common. So I'm factoring out a c. That is c times 1. So I have a 1 minus 2d left over. Now I'm going to look at this. It looks like I'm going to write this as a 4 times a d, and this is a -1 times a 4. So commons, a positive 4. So I'm going to say they have a positive 4 in common. Whoops. 2 times 4. Had it in my brain, just didn't get it written down. So they have a 4 in common. There is a 2d and a -1 left over. Okay, looking at factors that are left over very darn close, but again, we have opposite signs. So I'm going to leave my c, come on, 1 minus 2d. But what I'm going to have to do right here is I'm going to have to say that I'm taking out a -1 as well. And by doing that, I'm changing the sign. This 2d becomes negative. That -1 becomes positive. Does that help me out? Yep, it does. Because now, again, I have a -2d. I have a positive 1 that I see that we have in common. So I do have a common term that I'm going to rewrite as -2d plus 1. That I distributed that out, and now I'm going to multiply that by the factors that were left over. A c, 4 times a -1 is a -4. All right, your turn to try to give it a shot on guided practice 3B. Tricky one depending on how you factor it, but our first two terms have a p in common with the 3 and a -2p left over. Our second two have a positive 9 in common with a -2p and a positive 3 left over. So again, even though they are in different order, they both have a -2p, they both have a positive 3. So that wasn't an additive inverse. We could go ahead and distribute out the binomial they had in common and multiply it by the terms that were not factored. Okay, factor by grouping. Really, we want to focus on that distributive property. So now we're to the why part. Why are we doing all of this factoring? Because of the zero product property. We want to figure out what value we can plug in to these equations in order for all of this to cancel out and equal 0. Again, that's going to tell us many different things in story problems later on. Lengths and widths of things, okay, how much some type of item is going to cost. So we already talked about the zero product property. that any number times 0 is going to be 0. It doesn't matter where it is in the order of the whole term. As long as there's a 0 in a product, it's going to cancel it out. So when we look at equations like this with example 4, when it says solve each equation, again, since we are multiplying right here, if we put a 0 into this first piece, we know that no matter what number comes out of this piece right here, our answer is going to be 0. If we can get a 0 in this piece right here, again, it does not matter what we plug into this one. As long as this is 0, it cancels out. So when we have two parentheses like this, we set both pieces equal to 0. So that's the very first thing that we need to understand, that we want this first parenthesis to equal 0, and then we want the second quantity to also equal 0. Okay, so 95% of the time we are going to get two answers. So basically we are setting up two small linear equations. I did that kind of fast, but remember, add or subtract, so we subtract a 6 over, multiply or divide, so we divide a 2 over. So we could put a -3 in for this d right here in order for this to equal 0. Sure, this is going to be -24, but what's 0 times -24? 0. Okay, so could equal -3, or if we add 15 over, divide by 3, we could also put a 5 in there. So if we put a 5 in here, that gives us 16. But if we put a 5 in here, that gives us 0. What is 16 times 0? 0. Is that what we were looking for? Yes. Okay, and I did just check my solutions to make sure that that worked. B looks a little bit different. For one, it has a square on it, and we don't like squares. Okay, so let's go back to our introduction. If you remember, we were able to factor out that square and look at it in a different light. We could only do that, though, if it's set equal to 0. So that is step 1/2. If your equation is not set equal to 0, we're going to have to move him over and get it set equal to 0. How do you do that? How do you undo a positive 3c? You subtract it. So I'm going to rewrite this equation as c squared minus 3c equals 0. So now the question is, again, what could I plug in for this c in order for this to cancel out and equal 0? Well, over here they were nice enough to actually have this factored for us. This is not factored. So step 1, set equation equal to 0 if you need to. Step 2, factor. Why do we have to factor? Because step 3, set each product equal to 0 and solve. Okay, so step 1 and 2 was done for us for A. It's already set equal to 0. They had already factored it. But we did this third one. We set each product equal to 0, and we looked at them each individually. So we set it equal to 0 here. Now we have to factor. Again, what do each of these have in common? Looks like they all have a C, or they both have a C. So I'm going to factor out a C. And in parentheses, I have a C and a -3 left over. So I factored. Now it says I'm supposed to set each one of these products equal to 0. So I'm supposed to set just the C equal to 0. And that one's already solved. And that does make sense, because if I plugged a 0 in way up here, I would realize that that would equal 0, and we're all good to go. Okay, what else? I have a C -3 that I have to set equal to 0. So I need to add a 3 over. And I know that I could also put a 3 in, and that would work, because 3 squared is 9, minus 3 times 3 is -9, 9 minus 9 equals 0. Even way back up here, 3 squared is 9, 3 times 3 is 9, those do equal each other out. Okay, so steps on how to solve these. All right, with that in mind, go ahead and try guided practice 4. Okay, a lot of different concepts going on. Again, this first one, they already have it set equal to 0, they factored. So we are setting each product equal to 0, and we are solving. B didn't have it factored, so we factor out an 8B. It is set equal to 0, so we look at each product, set that equal to 0, and solve. C, we had to add a 10x over. We had to factor out an x. This one, as easy as it is, really trips up students that x just equals 0. We could plug a 0 in here and it does work. That is sometimes hard because they didn't have to solve anything. It was just done for them. Tell them it's an early Christmas present. One of the answers was already solved. The other one then, just subtract that 10 over. Okay, so follow those 3 steps and we should be pretty good. Now we get into the story problems. Where does this come into play? It says Penny is a fox terrier who competes with her trainer in the agility course. Within the course, Penny must leap over a hurdle. Penny's jump can be modeled by the equation h equals negative 16t squared plus 20t, where h is the height of the leap in inches at t seconds. We're supposed to find the values of t when h equals 0. Okay, there's a lot of things going on in this equation. For one, remind students that this negative 16 actually just deals with the gravity of Earth. And this 20t deals with how fast this dog is leaping. Okay, so this equation, again, a very fancy formula that physics people put together so we can go ahead and factor and solve. What are we solving for? H is the height of the leap in inches. So after a certain amount of seconds, we can figure out how high the dog is in the air. T is time. So we're supposed to find the values of t, the time, when h is 0. So what are we looking for? Well, this dog is starting on the ground where his height is 0. He or she, Penny, she is jumping, and then her height is 0 again. So visually, what are we looking for? We're looking for when she started and when she ended. So technically, what are we looking for? How long did it take her to do this jump? Okay, that's really in a nutshell what we're looking for. Well, before we can even do that, it looks like we have to go ahead and factor this and solve it. So again, they tell us h equals 0. So I'm going to write negative 16t squared plus 20t, and I know that they want us to have that equal to 0. So here we go. Let's go ahead and do some factoring. Again, I'm going to look in the future and I see 16 and 20, and I know that they have a 4 in common. So that's how I'm going to factor negative 16. There's a negative 1, there's a 4, a t, and a t. 20t has a positive 4, 5, and a t. Okay, which looks like we have a 4 in common and we have a t in common. So I'm going to factor out a 4t. What's left over? A negative 4t and a positive 5. And that's equal to 0. So what are we doing? We're finding the values of t, aka we're solving. So same as above, I'm going to set each one of these equal to 0. So 4t equals 0 and negative 4t plus 5 equals 0. So here, dividing a 4 over, I know time equals 0. Well, that does make sense because before she even started the jump, we know that the time was 0. Before she started, time 0. Okay, now we're going to actually figure out how long it took her to do this jump. So we're going to subtract a 5 over, so we get negative 4t equals negative 5. Divide a negative 4 over. Don't worry about these negatives. I know that we're dealing with the story problem, which you should be worried if we see negatives, but those negatives did disappear. So 5 over 4. Okay, since we're dealing with the story problem, let's go ahead and write that as a decimal, which is 1.25 seconds. So to answer the question, basically, how long did it take her to do her little jump? It took her 1.25 seconds. Okay, so understanding what it was that we were trying to solve for does really help sometimes to solve these. Okay, so Again, with all of that in mind, we went from Penny the terrier to a kangaroo. Go ahead and try guided practice 5. Okay, a lot of times when we're dealing with finding the time of something when the height is 0, we are going to get that time equals 0. Because again, before they even jump, they are on the ground, their height is 0. The biggest one is how long does it take them to complete that jump. For a kangaroo, it took 1.5 seconds. So again, this whole chapter, what we're doing is we're hitting that reverse button. We understand how to distribute. Now we are going to undo the distributive property by taking back those factors for reasons like this. So we can get rid of that square. We can focus on just that exponent of 1 so we can solve those equations. All right. Long section, a lot of concepts. We'll go ahead and try the assignment for this section.